Okay, so now we have, I think in the previous video we derived the formulas for basically for basically that was that we derived basically three formulas, or actually two formulas for the cross multiplication method of solving those linear equations. And now let's use it in order to basically do the example that we had in the beginning of the previous video. So we said that we said that the cost of 5 oranges and basically 3 apples was, or I could say is, basically $35. $35, and also the cost of 2 oranges and 4 apples is $28. So this is the information that I have related to this kind of situation. So basically this is the same oranges and the same apples and so on and so forth, and you want to know the unit price for the oranges and for the apples in this situation. So one thing that you can do is that you can take the unit price for oranges as X, and you can take the unit price for apples as Y, for example, and then based on this you can write two equations, meaning that 5 times X plus 3 times Y is equal to 35, and then you can write also 2 times X plus 4 times Y is equal to 28. Okay, and then of course you can use the method of elimination in order to solve this problem. For example, you could say that take this as equation number 1, take this as equation number 2, and then since let's say that you want to eliminate your y's over here, so you can basically multiply equation number 1 by the coefficient of y in equation number 2, which is equal to 4, and also multiply equation number 2 by the coefficient of y in equation number 1, which is equal to 3. Okay, so if you do that, what you will get is basically 4 times 5 is equal to 20x, and 4 times 3 is equal to 12y plus is equal to 4 times 35 is equal to 140. 4 times 30 is equal to 120. 4 times 4 is equal to 140. And then I call this equation number 3, for example. And then also you want to multiply equation number 2 by 3 here. So 3 times 2 is equal to 6x plus 12y is equal to 3 times 28, which is equal to 60, and 24, 84. Okay, so I call this equation number 4, and now if you want to calculate your y here, you can you can subtract equation number 4 from equation number 3. Subtract equation number 4 from equation number 3, which would be, just to subtract, you can take the algebraic opposite of all of these terms and then add them together. So these two will cancel out and that's basically what we wanted. 20 minus 6 is equal to 14x is equal to 140 minus 84 is equal to 140 minus 84 is equal to 0.13, and this is 10, so this is 6, 56, and then what you will have is 14 divided 50, x is equal to 56 divided by 14, which is equal to 4 times 10 is equal to 40, 4 times 4 is equal to 16, so that's 56, so that's equal to 4. So x is equal to 4, and then you can take any of these equations. For example, 5x plus 3y, 5x plus 3y is equal to 35, and then set x is equal to 4 in this equation to get y, meaning that 5 times 4 plus 3y is equal to 35, and then 20 plus 3y is equal to 35, and 3y is equal to 35 minus 1 is equal to 15, so basically y is equal to 15 divided by 3, which is equal to 5. So that means that the unit price for so x is equal to 4 and 5. Okay, so 4 and 5. So x is equal to 4 and y is equal to 5. That means that the unit price for the oranges was $4, and the unit price for the apples was $5. So now we can also, instead of doing all of this manually, we can use that formula that we derived in the previous video, meaning that I can write the same set of equations. 5x plus 3y is equal to 35, and 2x plus 4y is equal to 28. Okay, and then we said that basically in order to use those formulas, what you need to do is that basically the formulas were x, the way that you can remember them is basically you write x, y, and 1 over here, and then b, c, a, b. So you write here b, c, a, and b again, and then here you can write b1 and b2, c1 and c2, a1, a2, and b1, b2, and then you can cross multiply this way. So then you have basically x is the numerator, these are the numerators over here, so x is the numerator over b1, c2 minus b2, c1 is equal to y over a2, c1, these two multiplied together, minus these two multiplied together, so a1, c2, and that's equal to 1 over basically a1, b2 minus a2, b1. So that's the formula that we have. So what that means is that x over b1 c2 minus b2 c1 is equal to 1 over a1 b2 minus a2 b1, and also y over a2c1 minus a1c2 is equal to 1 over a1 b2 minus a2 b1. Okay, and that's basically the two formulas that you have. From this you can calculate your x, from this you can calculate your y. And so, and if you want to basically get x from this directly, from this formula, x times x is equal to b1c2 minus b2c1 over a1b2 minus a2b1, and y is equal to a2c1 minus a1c2 over a1b2 minus a2b1. Okay, and so that's basically the formulas that you have. And remember that when we derive these formulas, the equations that we had were in this form: a1x plus b1y plus c1 is equal to 0, and for example a2x plus b2y plus c2 is equal to 0. That means that the equations were written in general form, and these c1s and this c1 and c2 and so on and so forth are written based on the general form of these equations. So you have to write these in the general form, otherwise basically you are not going to get the right answer. So to write this in general form, I write this as 5x plus 3y minus 35 is equal to 0, and 2x plus 4y minus 28 is equal to 0. And so then based on this, a1 is equal to 5, b1 is equal to 3, c1 is equal to negative 35. That's why I said you have to write it in general form, otherwise you have a positive 35 here. And a2 is equal to 2, b2 is equal to 4, and c2 is equal to negative 28. And now you can substitute these values in these two formulas to get your x and y. So then your x is going to be equal to b1 c2, so b1 and c2 would be these two values: 3 times negative 28, 3 times negative 28 minus b2c1, so b2c1 is basically 4 times negative 35. 4 times negative 35 divided by a1b2. a1b2 is 4 times 5. 4 times 5 minus a2b1. So a2b1 is 2 times 3. 2 times 3, which is equal to 3 times 28 is equal to 60, I think 84. That's 60, and 60 plus 24 is equal to 84, so that's negative 84. Minus 4 times 35 is equal to 120, and 20, so 140 minus negative 140. You need to be careful here, otherwise, actually I did make a mistake over here, and I did make a mistake with these negative and positive signs, and I was actually looking for the mistake for a while. So that's equal to 20 minus 6. So this is equal to basically negative 84 plus negative into negative positive plus 140 over 20 minus 6 is equal to 14. So 140 minus 84 is equal to 0. This is 14, 13, 10. So 6, 56 over 14. 56 over 14, which is equal to basically 14 times 4 is equal to 40 and 16, so that's 56. So that's 4 times. So 4 is the value of your x. X is equal to 4, which is the same value that we got before. And now that I'm actually doing this, it seems that basically the method of elimination is probably most of the time, takes less time in order to calculate, because you have to write your equations in the general form, and then you have to solve, basically do all of this calculation. It seems to me that elimination is, at least most of the time, is easier. But, well, you can, for example, give this to a computer, and then the computer will have an algorithm in order to find the x and y's for you, for example. And then your y is going to be equal to A2C1, so A2C1 would be A2C1 2 times negative 35 minus A1C2, so 5 times negative 28, and then you have A1B2. A1B2 is 5 times 4, 5 times 4 minus A2B1, which is 2 times 3, 2 times 3. So that's equal to negative 70 minus, that's 5 times 28, which is equal to negative 140. So this is negative 140, and that's 20 minus 6, so that's equal to negative 70 plus 140 over 14, and that's equal to 140 minus 7 is equal to 70 over 14, which is equal to, I think, 5. That would be a 5. So y is equal to 5. So that is basically how you, for example, use this formula or these two formulas in order to calculate some results over here. So now let's go and do a couple of examples here. And actually I want to take these two formulas with me before I go anywhere, because I don't want to be deriving them over and over again. Okay. Okay, so now let's go and do a couple of examples. We'll find some good examples here. Okay, so we have a couple of examples here which have probably nothing to do with these two formulas, the formula that we just derived, but they are good examples. We can do them here. So if we want to know, we have basically two equations over here, two linear equations, which are 4x plus py plus 8 is equal to 0, and 2x plus 2y plus 2 is equal to 0, and this is a pair of linear equations. You want to know for which values of p does the pair of linear equations has unique solutions, has a unique solution. Okay, so you want to know for which values of p over here does this pair of linear equations have a unique solution. So a unique solution, we said that for a unique solution, we said that basically we had three cases over there. We said that if you have a unique solution, you have basically a pair of intersecting lines, and in this case A1 to B1, A1 to A2 is not equal to B1 to B2. Okay, so if this condition is fulfilled, then that means that this pair of linear equations has a unique solution. So that means that A1 to A2 is not equal to B1 to B2. Now here A1 to A2 is basically 4 to 2. 4 to 2 should not be equal to P to 2. P to 2. And I think you can of course you can simplify this here as, for example, 4 to 2 of course is equal to 2. So that means that P divided by 2 should not be is not equal to 2. And if I multiply by 2 here, both sides multiply by 2, P is not equal to 4. So that means that basically for all values of P except for 4, this pair of linear equations will have a unique solution. Otherwise, at P is equal to 4, the pair will not have a unique solution. Okay. Or as another example, let's say that you have, for what values of K will the following pair of linear equations have infinitely many solutions? Let's say that you have, for example, you have these two, you have this pair of linear equations, for example, kx plus 3y minus k minus 3, that's equal to 0, and then you have 12x plus ky minus k is equal to 0. And you want to know this is a pair of linear equations, you want to know for what values of k, does the pair of linear equations have infinitely many solutions. So infinitely many solutions, when you have infinitely many solutions, that means that we said that that was basically one of the three cases, and that's basically the case where the two lines are coincident. When the two lines are coincident, basically you have a pair of lines like this, which are basically coincident. Both the lines are basically represented by one single graphical representation. So, and in this case, basically A1 to A2 is equal to B1 to B2 is equal to C1 to C2. C1 to C2. Okay, so that's basically what happens here. So, now here, over here, basically in this basically pair of linear equations, your A1 is equal to K, and B1 is equal to 3, and C1 is equal to negative K minus 3, A2 is equal to 12, B2 is equal to K, and C2 is equal to negative K. Okay, so now let's see how we can solve this problem. So basically A1 to A2 is K to 12. K to 12 is equal to B1 to B2, 3 to K, is equal to C1 to C2, which is negative K minus 3 over negative K. Okay, so you don't really need to, so for example, you can solve the problem using these two parts. For example, you can cross multiply here. You can take these two parts. For example, K by 12 is equal to 3 by K, and so if you cross multiply, you'll get K squared is equal to 36, and K is equal to plus or minus square root of 36, which is equal to, so K is equal to plus or minus 6. So for basically for K is equal to positive 6 and negative 6, this pair of linear equations will have infinitely many solutions. And I think, oh, there is another part as well. So let me see. Well, actually, my answer was not wrong. It was not right either, meaning that the logic that I used over here to solve this equation was actually not right. So when you want to solve this equation, when we say that let me start over. Actually, this is pretty important. So when we say that basically our condition is basically this condition over here, that K by 12 is equal to 3 by K is equal to negative K minus 3 minus over negative K. Basically what that means is that basically this equation, you can think of it as basically two equations, meaning that I can write this as K by 12 is equal to 3 to K, which is equal to basically 3 minus K over, basically you can write it as K minus 3 over K. So negative and negative you can simply cancel out, K minus 3 over K. So it has basically two parts, meaning that it has this part over here and also this part over here. So how you can solve this equation is that basically first you can take the first part, meaning that K divided by 12 is equal to 3 divided by K. and so that means that k squared is equal to 36, and so k is equal to plus or minus square root of 36, which is equal to plus or minus 6. So here your k is plus or minus 6. But there is a second part to this equation, which is 3 to k is equal to k minus 3 over k. And then you can simplify this by basically getting rid of k from the denominators, meaning that you can simply multiply both sides of this equation by a k, meaning that you write this as 3k over k is equal to k minus 3 times k over k, and then you can simplify these two, then you'll be left with 3 is equal to k minus 3. So over here k is equal to 6. So since you see that over here k is equal to 6, and over here k is equal to plus or minus 6. Now the value of k that satisfies both of these equations, basically this equation number 1 and number 2, is k is equal to 6. So that means that from that you can conclude k is equal to 6 is the value for which this pair of linear equations will have infinitely many solutions. Okay, that's something I mean the logic that I used was actually not right, but it's a good thing that we took care of that problem. Okay, so in the next video we will go over probably a few problems related to this concept and the concepts that we have done before this, and then we still have a couple of things to do related to pairs of linear equations. So I'll see you in the next video. Thank you.